This video will show you how to check the multicollinearity assumption of multiple linear regression. The multicollinearity assumption is about the correlation of your independent variables. The assumption is that they are uncorrelated, that your independent variables have nothing to do with each other. This is often violated in practice, but it's only when you get really high correlations do you start running into trouble. Here's an example. I have a regression where I'm trying to predict classroom organization through a bunch of class climate observations: positive climate, negative climate, teacher sensitivity, regard for student perspective, and behavior management. I'm going to go to statistics and click on collinearity diagnostics. Click paste, find my syntax, run my syntax. And what I'm going to look at is the collinearity statistics, specifically the variance inflation factor. A variance inflation factor of 1 means that my independent variables are uncorrelated. Anything higher than that shows that there is some measure of correlation between my independent variables, which can be problematic. It can blow up my standard errors and make my beta estimates unstable, meaning that just small changes in the model will radically change what these things are. In this case, I have a variance inflation factor of 5.9 on teacher sensitivity mean cycle scores. This is above the rule of thumb of 4. If you have a VIF of 4 or more, you might be in trouble. Let's investigate this a little bit more. Let's go to Analyze Bivariate Correlations, and I've already put in my independent variables to see how correlated they are. Click Paste, find my syntax, run my code. I get my correlation table. Correlations are a measure of association between my variables. In this case, I have my independent variables for my regression. If you look at teacher sensitivity mean, I see a very high number. High number means close to 1, between itself and positive climate mean across all 4 cycles. It is also highly correlated with regard for student perspectives and for behavioral management mean scores across all 4 cycles. This means that there is too much overlap between my independent variables, and it is dangerous to include them all in my multiple regression. What I can do now is I could make a composite. I could take an average of all these independent variables and put those in. Another frequent solution is to simply throw out the problematic variables and just include the variables that are less highly correlated. Let's try that. Let's throw out teacher sensitivity mean and rerun the analysis. So I'll take this one out, paste, find my code, run it. Look at my variance inflation factors now. They are low. They are below 4. I can trust these estimates and their standard errors. This has been an example of how to check for multicollinearity in your multiple regression.